Okay, we'll continue on topics on applications of differentiation. One of the main applications of differentiation is optimization. What is optimization? It is to find the extremes of a function, the maximum and the minimum of a given function. For example, if I have a function like this, there are some points that are special for us. These points, the maximums and minimums, are special for us. So we need to find where would these points be. Okay, so this is the topic of optimization. First, we need to learn that we have learned that for a given function, how can I determine if a function is increasing? Through the derivative. How would I know if a function is increasing? Now, if you need to find that point, what is special about that point? That the function was increasing, then afterwards it is decreasing. Okay, so what determines if the function is increasing or decreasing? We learned that the derivative determines if the function is increasing or decreasing by its sign. We learned that the sign of the derivative determines whether the function is increasing or decreasing. Okay, so at a local maximum, what happens at a local maximum? The f dash, which is the derivative, is positive, then it becomes negative. It is increasing, then it becomes negative. That means that it is decreasing. Okay, and for a local minimum, a point like this, what happens to f dash? The function is decreasing, then it increases. So for a local minimum, what happens in a local minimum? F dash is negative, then it becomes positive. Okay, then it becomes positive. So I can know the point of a local maximum or a local minimum by the derivative. It is the point where the derivative changes its sign. Okay, it is the point where the function changes its sign. Let's first consider or define what is a local maximum or a local minimum. These points are called local minimum or local maximum. These are local maximum. These are local minimums, and these are local maximums. Why are we calling it local maximum? There is other maximum which is called absolute maximum and absolute minimum. What is the difference? A local maximum is a point for which the function is greater than its neighborhood. Okay, at this point it is greater than any other points in its neighborhood. Okay, in that point it's greater than its neighborhood, not overall the function, but only with respect to its neighborhood. Okay, but when I say absolute maximum, what is meant by an absolute maximum? It is the maximum of maximums. It is the point which is greater than any other value of the function. Okay, so that is called an absolute maximum. And so, for example, this is an absolute minimum for this function. Okay, but this is a local minimum. I can't say that this is an absolute minimum because there is another point which has a value less than this one. Okay, so we need to find the points where the derivative changes its sign. How would we find these points? We'll first call these points critical points. What are critical points? Critical points are the points for which have the potential to be a local maximum or local minimum. Okay, they have the potential. They are not necessarily a maximum or a minimum, but they have the potential to be a local minimum or local maximum. Okay, there is a great possibility that they will be a local minimum or local maximum. What are these critical points? He looked at this condition. When does the f dash changes its sign? It means f dash goes from a positive value till it becomes a negative value. It will certainly go through the point 0, where the f dash will be 0. So that point, that critical point where the f dash changes its sign, must have or should have a derivative which is equal to 0. How would a function change its sign from positive to negative unless it passes through the 0? Okay, so that's why a critical point, one of the main conditions to define a critical point there are the points which satisfy this condition, that the derivative is equal to 0. And this is obvious from this graph. For example, if you see here, you will find that at these points, you will find that the slope of tangent is just horizontal. Okay, the slope of tangent is equal to 0, which means that the derivative is equal to 0. But is this the only condition to be satisfied for a critical point? No. There may be other cases for which the derivative may change its sign. What are these other cases? When f dash is not exist. When f dash is not existent. Okay? What are examples of these? For example, if I have this function has a local minimum at this point, but the derivative does not exist here. Why does the derivative does not exist? Because if you find the slope of tangent from the left, you will find it that is different from the slope of tangent from the right. Whenever the slope of tangent from a side is different from the slope of tangent to the other side, when these two slope of tangents are different, we say here that the derivative does not exist. Okay? Now, there is a main condition for a critical point. Any critical point must belong to the domain of the function. So I cannot define a critical point where it doesn't belong to the domain. For example, if I had this function like this, would that point be a critical point? No. That point wouldn't be a critical point. Why? Because this point doesn't belong to the domain. Okay? So any point that is defined to be a critical point must belong to the domain. Okay? So whenever I have a problem and I need to find the local study the critical points and to find the local minimum and maximum, the first step is to find the critical points of that function. Okay? Then when I find the critical points, what should I do? I will study f dash. For example, I have found, that point x node, I found it to be a critical point. How would I know if it is a local minimum or a local maximum? By studying the sign of f dash. Okay? So in this case, I will just find the sign of f dash. For example, I would find it positive, then I would find it change to be negative. In this case, what does this mean? It means that the function increases in this interval, then it decreases in that interval. So that would mean that x node would be a local maximum. Yes. In this case, it will be a local. This is an indication that this point is a local maximum. Okay. So the two steps that I should do: first, to find the critical points. How would I find the critical points? By studying these two conditions. By studying where are the points that satisfy these two conditions, either of these two conditions. Okay? Then after finding the critical points, I would study the derivative, the sign of the derivative about or around these critical points. Okay? To know or to classify each point whether it is a local maximum or a local minimum. Sometimes I would have this case. To be positive, then it would be positive. Would that point be a local maximum or a local minimum? No. In this case, it would neither be a maximum nor a minimum. Okay? So, one of the known examples of f dash does not exist is the function of the absolute. For example, if I had this absolute, the absolute function, this absolute x, for example, x minus 2, at that point you will find that the slope of tangent in this from the right is different from the left. Okay, and so that in that case at x equals 2 the derivative does not exist, and at the same time that point x equals 2 belongs to the domain. So this point is considered to be a critical point, and it is obvious that it is a local minimum. It is obvious that, so this is one of the known cases for which satisfy this condition, which is at the absolute. Okay, so let's check an example. Given this function f of x equal x plus 4 over x plus 1, and he asked me to study the local extremes, to study or to find the local extremes of that function. Okay, so we have learned that the first step is to find the critical points. Okay, how would we find the critical points? First, to find the derivative. The derivative would be 1, and that would be minus, we have learned that 1 over something, the derivative would be minus 1 over that squared times the derivative of that thing. Okay, so that would be minus 4 over x plus 1 all squared. Okay, so that is the derivative of that function. Now I will study these two cases. First, the case when f dash is equal to 0, and the case when f dash does not exist. The first case, f dash is equal to 0, I will just say that 1 minus 4 x plus 1 all squared equal to 0. And so I'll take that to the other side. So d1 is equal to 4 x plus 1 all squared, which is x plus 1 all squared equal to 4, which means that x plus 1 is equal to plus or minus 2, and that means that x is equal to minus 1 plus or minus 2, which gives me two values, which is negative 3 and positive 1. Okay, so these are the two values that satisfy this condition, and these are conditions are considered to be critical points. Okay, neither of them does not belong to the domain, or both of them belongs to the domain, so they are critical points. Okay, now let's check the other condition. When would that derivative does not exist? When would that derivative don't exist? This derivative would not exist at the values that make the denominator be equal to 0. Okay, so in this case the derivative would not be existent. Okay, so at x equals negative 1, f dash does not exist. F dash does not exist at x equals 1, or I may say that f minus 1, f dash minus 1 is undefined or not exist. Okay, but should I consider it to be a critical point? Does this point belong to the domain or not? I check the original function. Does that point satisfy belongs to the domain of this function? No, because I have a denominator, and the domain in this case will just r minus the negative 1. So that point does not belong to the domain. So would that mean that this point is a critical point? No, this point is not a critical point. So it is not a critical point. Okay? So this one is rejected. Okay, so after finding, we have found all the critical points, which are negative 3 and 1. I will put it on the number line, negative 3 and 1, like this. Then I will check the signs of f dash. Now remember, we are checking the signs of f dash, not f. Okay, so I will just choose a number. Let's choose an easy number here, 0. Between these two, I will check, would I check it in here or in that function? On f dash, yes, I will check it on f dash. So putting x equals 0 in this expression, that would give me 1 minus 4, which is a negative which has a negative value. And when I put a value greater than 1, which is for example 2, that would give me 1 minus 4 over 9, that would be 3, so that would be, and that would be a fraction. 1 minus a fraction will just give me a positive value. And similarly for a value which is less than negative 3, for example negative 4 would give me negative 3, and it would also give me a 9, and that would be a fraction, so that would be also positive, it would have a positive sign in this case. Okay, so the function is increasing in this interval, then it is decreasing, then it is increasing again. So that would mean that this point is a local maximum. Yes, this is a local maximum, and this point will be a local minimum. That point will be a local minimum. Okay. Another example, f of x is given to be e power minus x plus absolute x minus 2, and check it for the local extremes. Check local extremes and find its range, Okay, let's check that. Now I need to find the derivative. I first need to find the critical points, but to find the critical point we need to find the derivative. So how would I find the derivative when I have an absolute function like this? Now remember, for this absolute, when I have an absolute function, it can be expressed like that. Take it as it is when that thing is greater than 0, and take the minus of what is inside when that is less than 0. Okay, that is the rule of expressing an absolute. This is absolute x, and x symbolizes any expression. Okay, this is when x is greater than 0, and negative x when x is less than 0. Okay, so for this expression, that would be expressed like that: e power minus x plus x minus 2 when x minus 2 is greater than 0, and e power minus x plus 2 minus x. Now I have taken the negative of that expression when x minus 2 is less than 0. Okay, and for the point at the 0, I may put it here or here. It is a continuous function, so I may put it belong to the first branch or the second branch. It doesn't matter. Okay, so I put it here or I put it here. That condition I will rewrite it just to be, it is better to be written as x greater than or equal to 2. X greater than or equal to 2. And that other condition will just make it to be x less than 2. Okay? Now this is the function re-expressed in that form. Let's find the derivative of that function. So f dash in this case would be, to find the derivative of that function, that is minus e power minus x. The derivative of an exponential is the same, but I multiply it by the derivative of what is inside it. What is inside is minus x, so its derivative is minus 1. Plus, what is the derivative of this term? It is 1. Okay, that is for x greater than 2. And for the other branch, it would be minus e power minus x, but now it is minus 1. The derivative of that term is minus 1. And this is for x less than 2. What about the point x equals 2? Now, it was continuous, the function itself was continuous at that point. But when we find the derivative, it may not be continuous, or it may not be existent. Why? Let's check. How would I check the derivative at x equals 2? How would I check the derivative at x equals 2? I will just find f dash of 2 plus and find f dash of 2 minus. What is f dash of 2 plus? I need to substitute with 2. What is 2 plus? It is just the number besides 2 from the right. It is 2.00001. So what does that, for which branch does this number belong to? The first or the second? It is that number. Is that number greater than 2 or less than 2? It is greater than 2, so it belongs to the first branch. So when I need to find f dash of 2 plus, I substitute it in the first branch. So that would be e power minus 2 plus 1. But when I find 2 minus, what is 2 minus? It is just the number before 2. The number that is beside 2 from the left, which is I may call it 1.999999 and so on. So that number is greater than 2 or less than 2? It is less than 2. So it belongs to the first or the second branch? To the second branch. So that's why I substituted in the second branch, so it would be e power minus 2 minus 1. Now when we look at these two values, are they equal? No. So what does that mean? It means that the derivative from one side, different from the derivative from the other side, and that means that f dash of 2 does not exist. When these two values are not equal, and these two values are not equal, so that means that f dash does not exist. Okay, it means that the slope from two sides are different, so f dash does not exist at x equal 2. So that's why we do not put the point 2 with them. I say undefined or not exist at x equal 2, not exist. Okay, so now let's check where are the critical points of that function. Let's rewrite the f dash. I will rewrite f dash of x. It was equal to minus e minus x plus 1 and minus e minus x minus 1. That is for x greater than 2 and x less than 2. So let's study the two cases. When would f dash equal 0 and when would f dash does not exist? We have just mentioned that when does f dash does not exist? When at x equals 2. Now, does x equal 2 belong to the domain of the function or not? Now this is the original function. Does x equal 2 belong to the main function? Yes. It is continuous and I may put x equals 2 with no problem. Okay, so it belongs to the domain. It belongs to the domain of the function. So would I consider x equals 2 to be a critical point or not?
Yes.
Yes, it is a critical point. So this is a critical point, which is one of the critical points. Okay, so let's check the other condition. How to find if f dash, for that f dash is equal to 0. I need to solve that equation. When would that equation equal to 0? To check a function that is expressed in branches like this to be equal to some number, or to solve an equation like this, I would solve it for the first branch and check the solutions if they satisfy the condition of that branch. So let's check the first branch. E power minus x plus 1 equal to 0. When would that be equal to 0? So that means that e power minus x is equal to 1. And that means that minus x is equal to ln 1, which is 0. So that means that x is equal to 0. So is that a solution of that equation or not? I need to check if it satisfies the condition of the branch. I have found the solution for the branch. So any solution to be accepted, it must satisfy the condition of that branch. Does x equal 0 satisfy the condition of the branch? No. X is 0 does not belong to the from 2 to infinity. So it is rejected. It is not considered to be a solution. Okay? So let's check the other branch. Minus e minus x is equal to minus 1 is equal to 0. And that means that e power minus x is equal to negative 1. Yes, this equation is rejected from the beginning. I cannot say that ever an exponential is always positive. It is never negative or never 0. So that equation is rejected. Even if I try to take a ln both sides, I would find it ln negative 1. Could a ln be found for a negative value? No. So this is rejected. So that condition is not satisfied either by the two branches. Okay? So there is only one critical point for this function, which is x equals 2. So I just put it on the number line like this. And I check f dash. The sign of f dash. I choose a number greater than 2 and I choose a number less than 2. Let's check this easy number, which is 0. I put 0. 0 would belong to the first branch or the second branch in f dash? 0. The second branch. It is less than 2. So it is e minus e power 0, which is 1, minus 1 minus 1, which would be negative. And for the second, which I choose, for example, 3, that 3, it will belong to the first branch, which is negative e power minus 3, that is a positive value. So it will give me a positive value. Because e power minus 3, that is a fraction. E power negative 1, it is just e1 over 3 power 3 minus 1. So that is a fraction. 1 minus fraction is just a positive value, like this. So that means that the function is decreasing, then it is increasing. And that point would be a local minimum. Okay? Now, in the other requirement, he tells me to find the range. We have learned many methods to find the range of a function. Add to them another method, which is by finding the maximum and the minimum. So, for example, if I had this function What is the range of this function? If I find the minimum and I find the maximum of this function, that is exactly the range of the function. Okay? So for this function, I have learned that it has a minimum at x equals 2. This function has a minimum at x equals 2. It has a minimum. Okay? I don't know what is the value of the function at that point, but it has a minimum. Okay? Then it doesn't have a maximum. I've learned that it doesn't have a maximum. So it just goes to infinity like this. So what is the range of this function? It is starting from that point. I still don't know what that value is, but from that point to infinity. Okay? So the range of that function, it is just f of the range of the function is f of 2 to infinity. What is f of 2? I just go to the original function, which is f of x equals to e minus x plus the absolute of x minus 2. Okay, and put x equals 2, it will just give me e power minus 2. F of 2 will just equal to e power minus 2. So that the range, I will know that the range of this function would be e power minus 2 to infinity. Okay, so that is how I find the this is how I find the another way to find the range of a function. Okay. So we have learned about the local extremas. What about the absolute extremas? For absolute extremas in a given interval, in a closed interval. When if some interval is given to me and I need to find, for example, this function. It is given to me in a given interval from a to b. Okay. Now I need to find the absolute maximum and the absolute minimum. Okay. So what is the absolute maximum and absolute minimum? It is the maximum of maximums. And what is the absolute minimum of minimums? Okay. So these are the critical points. This is 1 and this is 1 and this is 1. These are the critical points. These are the critical points. Okay. But what is the local minimum for this function at this interval from a to b? What would you think the local minimum would be in this case? The absolute minimum. What is the least value of the function in this interval?
B?
Is it this? Is that the least value of the function? No, we have this point. Yes? This point. But this point, is this point a critical point? No, this is not. It is just the boundary of the interval. Okay? So when I check the absolute extremes, I include in my test the boundaries of the interval. I include in my test the boundaries of the interval. So how to find the absolute extremes for a given function? I find the critical points and the boundaries, and I check the image of all of them. I find f of all of that, then I find the maximum and the minimum and determine where would they be. Okay, let's check that in an example. For example, find absolute extrema for f of x equal to x cubed minus 4x plus 5 over the closed interval (1 and 4). Now he's giving me a closed interval to check for the absolute extremes. Okay, so I will need to find the critical points of that function. Critical points. To find the critical points, I check f dash, which is 3x squared minus 4, and I put it to be equal to the function is over 3. So that would be x squared minus 4. Okay? Now, for that function, I need to find when f dash is equal to 0 and when f dash does not exist. F dash is equal to 0 at x squared minus 4 equal to 0, and that is x equal to plus or minus 2. Okay? And for that one does not exist, it will never be not existent. Okay? There are no points that make a problem for me. There is no denominator, there is no branches in the function. Any of these does not, there is no value that make the drift does not exist. So I have two critical points. So are all of these critical points belong to this interval? He is testing the function only in that interval. Are both of them in the interval? No. Yeah, I will just have 2 and negative 2. This does not belong to the interval. So I will just take it out of my test. I will just check. Now I will just check the critical points, which is 2. I will check f of 2, and I will check the boundaries of the function, which is f of 1 and f of 4. I will check the values of the three points. Okay? Then let's check the 3. That will give me negative 1 over 3. And that will give me 2, and that will give me 5. So what is the absolute maximum of this function? Absolute maximum, it is 5, yes, and it occurs at x equal 4, which is the boundary. What is the absolute minimum? It is negative 1 over 3, and it occurs at x equal to 2, which was the critical point. Okay? So this is how we check for an absolute extreme. The way we have determined if the function having a local maximum or local minimum, we considered only the first derivative. For any of the studied problems, we have studied the derivative, the first derivative, and we checked if it is positive, whether it changes its sign or not. Okay, so that is called the first derivative test. That is called the first derivative test. There is another test which is called the second derivative test. We have learned that around the critical point, if I have the derivative is like that. Okay. So that is the first derivative. So what happens to the derivative in this case? This is a local maximum. Okay? What happens to the derivative in this case? Is f dash along the number line around x node, does it increase or does it decrease? When it is moving like this, it is positive, then it is 0 or does not exist, then it becomes negative. So in this, on its way, is it increasing or it is decreasing? It is decreasing. So f dash is decreasing. So for a local maximum, f dash is decreasing about it. So what is meant? How to determine if a function is increasing or decreasing? It is by the derivative. So what you are telling me here that f dash is decreasing, it means that the derivative of that function is negative. Okay? So what is the derivative of this function? It is the second derivative. The derivative of this function is the second derivative. So I am saying here that the derivative of f dash is negative. That means that f dash, the derivative, it means that the derivative of f dash is negative. And that means the derivative of f dash, what is the derivative of f dash? It is just f double dash. It means that f double dash is negative. So for a local maximum, if another way to check if it is a local maximum or local minimum, if the second derivative at that point is negative, I would know that it is a local maximum. Okay? And the opposite just occurs for the local minimum. Local minimum, in this case, it is just negative then positive. It means that the first derivative is increasing. And what is meant by the f dash is increasing? It means that the derivative of that function, which is just f double dash, is positive. So for a local minimum, it means that the second derivative is positive. Okay? So that is called the second derivative test. Instead of studying the sign around or about the critical point, we may just find the second derivative at that point. Okay? If it is positive or it is negative. Sometimes the second derivative would be 0. In this case, if the second derivative is 0, I cannot determine if it is a local maximum or minimum or any other case. Okay? So, or neither. So in that case, we say that test failed. It may either be a local maximum or local minimum or some other point, neither this or that. Okay? So that is the subject of optimization.